Procedural generation. What actually is it? You see, most games are designed statically, meaning their content is designed up front and doesn't change later at any point. Its content, the same, frozen in time, forever. While this is popular, many games employ a method called procedural generation, a method of generating content dynamically as the game plays out. This has the potential to create many different gameplay experiences each time you play through the game. Okay, let's just pause for a second and outline why I actually need this. I'm developing a mobile game where I'm trying to distill the most interesting aspects I feel of an RPG game, the exploration, down into a simple mechanic that fits well on a mobile device. As part of this, I've developed an exploration screen which shows you what's going on in the exploration at any given time. Let's take a look at that now. Oh, I'm sorry, I think my brain just disconnected from my body. How boring that is. This is always just a placeholder, so let's spice it up a bit.
Spicy.
Before embarking on any adventure, one must first read around a bit and learn all the things that one needs to learn about the problem at hand. I found lots of useful articles while researching this. One of the most useful ones was this one, where I learned lots about what was actually needed for the problem. Hey, look at those sliders. For my project, I decided I wanted to have landmasses, rivers, towns, and potentially roads, biomes, and some other things. If done correctly, I could generate an infinite number of worlds with only a few parameters. I actually got quite a bit of that done this month, so here's a sneak preview. Oh, I'm sorry, did you miss it? Well, you have to watch the rest of the video then. I settled on using Perlin noise for this rather than the Veroni approach that the other people used. Perlin noise was originally developed by some Giga Chad named Ken Perlin, who wanted to create an algorithm to produce more natural looking formations. Wow, look how wavy it is. I built support for generating noise right into my engine. I'm developing my own engine, by the way. One problem though, it doesn't really look like anything natural. Playing around with some of the numbers, I managed to make it look a bit more like an island. So I did a length of line equation from the centre to figure out this interesting circle pattern. Hey look, I actually did use some of the maths I learnt at school. Guys, I actually got a B in A-level maths, where B stands for big brain. From this, I could multiply the two together to get this interesting island effect. Hooray! But it was at that point, everything changed. Now there are two approaches to this. Ideally, I want the world generation to be as fast as possible, while also as flexible as possible. What you're seeing here is entirely being processed on the GPU. I am uploading Perlin noise data to the GPU, where I am then processing it with shaders to make it look interesting. The problem is that in most cases, you need concrete data on the CPU, somewhere that you can read from it. The main downside to this is that it's a bit slow. The CPU isn't really good at doing this sort of job in high frequency. There are ways to optimize it, but I won't go into them here. Regardless, I set about recreating my work on the GPU to the CPU using my embedded scripting language. I spruced everything up in my inspector tool and it was looking real nice. But what can be done to make this more interesting? Ah, Floodfill. Most of you know him as the paint bucket tool in MS Paint. But did you know, Floodfill is really just a simple algorithm to fill a space? What does that have to do with this project? Well, look at these bits of water. They're not part of the ocean, are they? It would be useful to categorize which bits of the map belong to different classes, so we can visualize them differently. From a gameplay perspective, you could have different things spawn in a lake compared to the ocean, or vice versa. Boys, here's the plan. Start from the top left, moving right. If you find a tile that hasn't been added to the list yet, begin the interrogation. For a Floodfill, all you do is check the corner tiles of each tile, moving outwards recursively. Once the seed X and Y has been categorized, you continue the search until every piece of water has been checked. At the end, sit back with your completed list of data and rejoice. Also update the shade a bit to be able to visualize the data. Well, that looks nice. If we make the assumption that our ocean begins at tile 00, then we know which bits of water are ocean and which are lake. Do a similar thing with land masses to be able to categorize them in a similar way. I have a question. Yes, what is it? What are those? Yes, well, unfortunately, as part of the polar noise equation, we sometimes get these smaller land masses left over. Luckily, as we've taken the time to do Floodfill, we can quite simply get rid of them. Okay, well that was a lie, it wasn't actually that easy to get rid of them. Let's just take a moment to think about this. The map still looks like this. It's based on altitude rather than actual island data. Which means that if I want to get rid of those land masses, what I actually need to do is drop the land mass down. What if that updates any of the land features? Do I have to update that? What about the parent water body? Would that have to absorb the vertex count? I have to make sure they're properly classed as water now. Why does the viewer still look like this? Do I have to update both my land masses and water feature lists? Yeah, suffice to say, that wasn't as easy as I thought it would be. But it does look better now. Rivers. Since the dawn of time, these blue snacks have been terrorising the landmass. But did you know there's a reason for all this? Water Brexits from the ocean to go and live in the mountains, where it falls back down as sky juice, technical term, before falling back down to the ocean where the whole pointless cycle can begin again. How magical! So this whole thing is based on gravity and altitude. Wait, I have altitude? I could do rivers. Attempting to get some rivers generated on my project, I wrote this code to help me find the highest altitude on the map. Don't look too hard at it. From here, I wrote some more nasty code to try to trace down the altitude to find the ocean. Oh wait, that's a sign that things weren't as easy as I thought they would be. See these sand dunes here? Well, the way I got this to work was that I generated a certain interval where sand would be generated on top of the landmass, which of course gives the effect of beaches, but what it actually means is that any place inland with sand dunes is an area of low altitude. The problem with this is that if the river ever finds its way into one of these sections of low altitude, it will never be able to leave. Like the average crypto wallet, it was a bumpy road down. I tried numerous methods in order to get the rivers to behave like responsible adults, but I just couldn't find it. Oh wait. No, sorry, I thought I had an idea there. Wait, I have an idea. Alter the Floodfill algorithm to get it to keep track of all the edges. Pick a random point on the coast and trace uphill. That's not how gravity works, bro. Hey, if it works, it works. Boys, we got some decent islands going on here. Let's play some settlements. This game is pseudo-random, meaning that the content that appears in the exploration screen is procedurally generated, but the content that appears in the towns and places is all designed with a traditional level editor. Let me just read you out a description of some of the places in this game. Garreton, the capital city of the kingdom, built alongside the river and by the ocean. Rutherford, a small decaying settlement plagued by a monster which lives in a house nearby. One of the requirements I have is that when placing a settlement in the overworld, I need to make sure that its position makes sense in terms of the context of the location. So for something like Rutherford, I need to make sure that I can specify a dependency on the old manor so that it spawns nearby to where the town settlement is actually placed. This means that when the player receives the quest to go and kill the monster that lives in the house, they know that they only have to walk a certain distance from wherever Rutherford is placed in order to take part in that quest. I designated different classes for the different settlements so that I could do things like specify that you can only have one city spawn per map. I've also got others like minimum land masses, rarity, and importantly, necessary features. I'm using a bit mask for this so that I combine certain objects together. For instance, say a city has to be placed alongside a river but also by the ocean. At the moment though, this is only really half done. I got it visualized nicely in my editor tool, but I decided that for the end of the month I would try and do something interesting. Hey, we got ourselves a pretty snazzy pixel world there. But wait, the other day I was told that there's a third dimension. I know, right? Who'd have thought? We are going to need to get this world into a Minecraft looking thing at some point. So why not now? I was originally thinking that we were going to have to use marching cubes for this. A pretty simple algorithm that allows you to visualize something in 3D space. But then I realized, we're dealing with voxels here, chaps. A very simple form of geometry, because everything's basically just a square. Yeah, sorry guys, yeah, sorry. Sorry, I didn't think I'd have to get you out, but you know how it is. So if not marching cubes, how did I do it? You give the system an array input of voxels, with values between 0 and 255, where that value represents colour. And in my case, I use null to represent no voxel at all. For each voxel, you check along its 6 faces, and see if it has a neighbour on each face. If it does have a neighbour on that face, then you can simply avoid writing it to the vertex soup, because this allows you to filter based on which sides of the voxel are actually visible. If all goes well, you should just be able to write your voxel values to an array and give it over to the system. So let's see how that looks. Pretty acceptable. In case you're wondering, I did build this system with the assumption that I might be using it for other things in future. The main example I'm thinking of is that in future I might want to have ways to combine, say, a player model with an item to visualize the player having equipped an item. What I'd be able to do in that case is generate a new model that is efficient to draw and will represent the player equipping the item. This would be good for things like armor as well. With all that said, let's see what this bad boy can do. Oh god! Well, turns out there's problems with it. I didn't quite have the time to fix it. I actually stole some of this code from the Goxel source code. Sorry, took inspiration from. Some nice diagrams there, lads. I think it's a simple fix, but my hypothesis is that my check to see which voxels neighbour which voxels is completely whacked. This probably has more to do with the changes in coordinate systems between Ogre and Goxel. But the end of the month was coming and I needed to start editing this video, so let's just disable all optimizations and see what it does. Oh, it's taken a while. It's a bit painful to watch, really. Oh, sorry, I thought it was going to do it then. Oh, look, there it is. Oh, it works. Hooray. Hooray. Woo! Woo! That's pretty nice. Now, of course, this thing does have lots of improvements that can be made. The main one being that the code that runs it is complete f***. But I think progress is progressing. Oh, it almost brings a tear to my eye. Next month, I plan to properly integrate this with the rest of the game. I plan to get the most important gameplay aspect of this game, the exploration, to actually be fun by integrating everything that we've developed this month. I do have a plan for each month of this year, so basically guys, subscribe!